Welcome back, everybody. We're continuing our chapter on trigonometric identities. Today in section 4.2, we are proving identities. Now, I know what you're thinking, proving as in proofs. Okay, like geometry class, kinda, sorta, don't worry about it. This will be more fun. All right, here we go. So let's jump right into a proof to show you how these work. Problem 1 says, prove the identity. And what I have here is a kind of ugly looking trig identity to prove. Now this one's actually going to work out pretty simple once we show you how to do it. And the way we can think about proving a trig identity is essentially I'm going to take one side of the identity, so a trig expression, and I'm going to simplify it down until I get the other side. So essentially what I'm doing here is I'm simplifying identities where I already know what the answer is going to be equal to. I already know what the end result is. Okay, I just have to prove it. I have to prove why it's true. Okay, proving identities, you always want to start with the uglier side of the equation, with the more complicated side. I'd say between the left and right side here, the right side's clearly more complicated. There's more stuff going on. So let's say I have cosine x times secant x minus cosine x plus cosecant x times cotangent x. So we'll start off with that right side. And what I'm going to do is I'm just going to keep rearranging, keep reducing, keep simplifying this until I end up with the left side. Now what I'm going to use to simplify it, I'm going to use the same fundamental identities from last section. Okay, so no new identities to work with, same ones from last section. And I'm also going to use a lot of the same tricks, a lot of the same methods we used last section in the proving section here as well. Okay, we'll show you a few different ones, but basically if you can simplify an identity, you can prove an identity. Okay, so let's start working with this expression here. First thing I can do is I can get rid of my parentheses by distributing. I'm going to distribute the cosine times all three terms inside the parentheses. That's going to give me a cosine x times secant x. Minus cosine times cosine, we'll say, is just a cosine squared x. And then plus cosine times the cosecant cotangent, we'll just say for now is cosine x times cosecant x times cotangent x. Okay, what can I do from here? Well, I can switch everything to sines and cosines and see if anything cancels, see if I can combine anything. Okay, cosine x we'll just leave as cosine x over 1 times secant, which we can call 1 over cosine x. And we'll reduce that in a second. Okay, negative cosine squared we'll just say is a negative cosine squared for now. We'll leave that alone. All right, plus cosine times cosecant times cotangent, we'll write that as a cosine x over 1 times cosecant, which is a 1 over sine x, times cotangent, which we'll say is a cosine x over sine x. Okay, what can I do with this? Well, like we said in the first fraction, we can reduce. Cosine over cosine is just a 1. So we'll say 1 minus cosine squared. All right, plus with this last fraction, we can't cancel, but we can multiply across the top. Cosine times cosine will give me a cosine squared. And sine times sine will give me a sine squared on the bottom. Okay, where do I go from here? Well, what I'm shooting for is a sine squared plus a cotangent squared. I want to show how what I'm left with gets me there. Well, I'm going to say I have one step left. First thing I can do is if I use Pythagorean identities, a little scratch work here, we know that sine squared x plus cosine squared x is equal to 1. So if I subtract cosine squared x from both sides of that equation, what I end up with then is sine squared x is equal to 1 minus cosine squared x. Okay, so in other words, instead of 1 minus cosine squared, I can just say sine squared x, which is this first part of what I was shooting for. And then I know that cosine over sine is cotangent, so meaning cosine squared over sine squared is cotangent squared, which is this other piece. All right, so there you go. There's our proof. We just showed step by step why the right side of the equation is equal to the left side. Okay, as far as what my answer is, what I'm not going to do is I'm not going to circle this last step here. I already knew that was true. Basically, the answer I'm looking for with my proof is all this stuff in between, which shows how I got from one side to the other. Okay, that's the idea behind proving a trigonometric identity. To generalize that then, the steps we just went through is we started with a more complicated side. It's always going to be easier to go from complicated to simple than it is to break simple things up into complicated. So start with a more complicated side, and we'll talk about how to tell what that is as we go through examples today. Okay, the bulk of the proof is showing a sequence of equivalent expressions working towards the other side. That's the majority of the work. And then step 3 is you end with the opposite side. You end with the other side of the identity. Okay, and then like we said in this step 2 here, what are we doing? What are we using? Well, we're using those same fundamental identities from last section, okay, to reduce down the expression until we get to the opposite side. So basically a proof is a lot like simplifying where we already know what the answer is. All right. For the rest of this lesson today, what I want to do is tackle 2 specific types of proofs we're going to look at. Just like there were certain types of simplifying problems, we're going to see certain types of proving problems. And in a lot of cases, we're doing the exact same things we did with simplifying. First one I'm going to call an adding fraction example. Okay, so once again, prove the identities. And I'm going to say adding fractions because this cosine squared and cotangent squared are really just fractions in terms of sines and cosines. We want to put them together, okay, to get the right side of the equation. Now, how do I know I want to start on the left side here? Well, it's always more difficult to add and subtract fractions than it is to multiply. So I'm going to say with this one, the adding is the more complicated side than the multiplying side. Okay, so let's start off with cosine squared x minus cotangent squared x. And to get the fractions, I'm going to rewrite this in terms of sines and cosines. So we could say we have a cosine squared x over 1 minus cotangent squared, we could say is cosine squared x over sine squared x. Okay, now to put these together, I need a common denominator. So as a side step here, I'm going to multiply both sides of this left fraction by the sine squared. Okay, because that's what my denominator is missing. And what I'll have then is we can write this as one fraction. I can say sine squared x times cosine squared x minus cosine squared x. And that's all over the common denominator of sine x. Sorry, sine squared x. Okay, so I've gone from 2 fractions being subtracted to a single fraction, which is what I'm looking for. Okay, just 2 things multiplied together. What can I do next? Well, I can't cancel the signs because there's not a sign in both terms. What I can do, though, is since there's a cosine in both terms of my numerator, I can factor that out. I can rewrite this as cosine squared x times sine squared x minus 1 over sine squared x. And then the trick I'm going to use next, just like in the last problem, I'm going to look for a Pythagorean identity. Now, anytime you see stuff squared plus 1 minus 1, think Pythagorean identities. I'm going to replace this 1 minus sine squared piece. And to do that, let's do a little scratch work. We'll go up top here. Again, I know that sine squared x plus cosine squared x is equal to 1. And rearranging this, if I subtract 1 from both sides, and also subtract cosine squared x from both sides, I'll end up with, on the left, sine squared x minus 1, And that's equal to, on the right, a negative cosine squared x. Okay, the sine squared x minus 1 is what I want to replace, and I can replace that with a negative cosine squared. Now, with a proof, I can kind of pay attention to what I'm shooting for. I want to get to this right side of the equation. It's got a negative in it, so I know I'm probably on the right track here. So let's give myself some room here. I can rewrite this as equal to cosine squared x times, we'll say, negative cosine squared x all over sine squared x. And then from here, I can just rearrange this. I know that, well, I need a negative cosine squared. I've got that. And then I want a cotangent squared. Well, once again, cosine squared over sine squared is the cotangent. So I can just say times cotangent squared x at this point here. All right, there's my proof. That's where I got from the left side to the right side with this one. All right, part B is another adding fractions problem. Let's say take a minute, pause the video, see if you can work through part B, and then hit play to either check your answer or to get some help if you get stuck trying to prove that one. All right, let's run through part B quick. Adding fractions. Again, I want to start off with the adding. We're going to say that's always more complicated than multiplying. So I'm going to start off with tangent x plus cotangent x. Okay, I can rewrite that in terms of sines and cosines. I can say tangent is sine x over cosine x. Okay, plus, I'm going to leave some space here so I can multiply. Cotangent, we can say, is cosine x over sine x. Okay, if I want to put these together, I need a common denominator. Okay, well, that'll just be a sine times cosine. My first fraction is missing the sine, so I'm going to multiply that by sine x over sine x. And my second fraction is missing the cosine, so I'll multiply by cosine x over cosine x. And that's going to leave me with, for the first fraction, we'll have a sine squared. Okay, plus the second fraction, we have a cosine squared. And that's all over the sine x times cosine x. Okay, sine squared plus cosine squared, we know that's a basic Pythagorean identity. That's just a 1. So I can say we have 1 over sine x times cosine x. And what am I shooting for? I'm shooting for a secant times cosecant. Well, 1 over sine's the cosecant, 1 over cosine's the secant. So I can just say right here that this is equal to the secant x times cosecant x. Okay, we got to back to the left side, so I know my proof's done. We just proved why the right side equals the left side. All right, last type of proof we're going to talk about today, I'm going to say is a pulling fractions apart problem. Okay, we just looked at adding fractions, subtracting fractions. Here we're going to separate fractions. We're going to pull them apart. So let's show you how this works. Prove the identity. Now, as far as which side's more complicated, I'd say in this case the right side is more complicated. Left side we've got adding fractions, but the right side we have adding fractions on top of another fraction within another fraction. Okay, so let's start off with the 1 plus tangent. Okay, it's not a u actually, it's a mu, fancy Greek letter, or you can just call it u, doesn't matter. And the reason I know this is a pulling fractions apart example is I want to go from one compound fraction with addition in the numerator to 2 separate fractions. So what I can do is I can rewrite this as 1 over sine plus a tangent over sine. Okay, and why does that work? Well, if we think about going backwards, if I want to add these 2 fractions together, I'd take my common denominator, I'd add the numerators over the common denominator. Okay, here I'm just doing the opposite. I'm splitting the numerators apart over that common denominator. Okay, working towards the other side then. 1 over sine, I can just rewrite that as cosecant, which is what I'm shooting for. Okay, then plus with the second fraction, there's a little more work to show. I want to show how this reduces down to the secant. Well, to do that, I'm going to switch to sines and cosines. I can write my tangent as a sine over cosine. And then that's all going to be over the sine, which we can say is a sine over 1. So here we're dividing fractions. So we've got our cosecant part of it done. Okay, plus then for the division, I can switch that to multiplication. We'll leave the first fraction right side up. So sine u over cosine u. Okay, then times second fraction flipped upside down, so that's going to be a 1 over sine u. Okay, here the sines will cancel, leaving me with just a 1 over cosine. So to finish this up, I can rewrite it as cosecant u plus 1 over cosine is a secant u. All right, which is what I was shooting for with this identity. Okay, again, that's an example of pulling fractions apart. Part B is the same idea. I want you to take a minute to give it a shot, pause the video, and then press play to make sure you're doing it right. All right, like we said, part B is another pulling fractions apart proof. I want to go from a fraction with addition in the numerator down to, in this case, we just have one part, but what we'll show you is that I really have two things here if I think in terms of Pythagorean identities. All right, so we'll show you how to wrap this one up a little bit different. Okay, so I'm going to start off with the more complicated side, cotangent y plus tangent y over tangent y. I'm going to split that fraction apart. Okay, so we could say cotangent y over tangent y plus tangent y over tangent y. Okay, so the numerator is split up across the common denominators. Okay, just like with the last problem, I'm going to flip this first fraction to sines and cosines. So cotangent we could say is a cosine x, y. If you switch, doesn't really matter. Over sine y. Okay, divided by tangent, which is the opposite, which will be a sine y over cosine y. Okay, plus, and for the second fraction, we can just cancel that at this point and call it a1. Okay, let's take care of this division by multiplying. Okay, so first fraction right side up, we could say is cosine x over sine x. Y's. Second fraction flipped upside down will be again cosine y over sine y plus 1. Okay, so what I'm going to have here then is cosine squared over sine squared. And I know that cosine over sine is cotangent, so this first piece is just going to turn into a cotangent squared, and then plus the 1. Okay, to finish this off then, to get it to the cosecant squared, we can just use our Pythagorean identity. I know that cotangent squared plus 1 is just equal to cosecant squared. So I can finish my proof by just saying that we know that's equal to the cosecant squared. Okay, there we go. My proof is done. All right, so there you go. There's part 1 of our proving trig identities lesson. Okay, so start working on the homework. Now with this homework assignment, I'm not going to give you a specific number of problems to start working on. I'm just going to say do the ones you can at this point. Okay, so in other words, look for the ones that are adding the fractions. Okay, look for the ones that are pulling fractions apart. There'll be a few other simple ones where you distribute or factor, kind of like we did with the first example. But part of this process is deciding what to do, so I want to make that as part of the homework, figure out which ones you're able to do at this point, and then in part 2 we'll show you how to do the rest and you can clear them all out. Okay, so give that a shot. Like always, if you need help, let us know, get some help. We're here to help you out.